Hey, it's Szymanski here, your friendly neighborhood physics teacher. We're going to talk about net forces, and so I'm going to do kind of our normal breakdown of a net force situation and solving for some variables. So, in fact, this one's going to be a two-parter, so I'm going to do one for a certain plane, then one for the other plane. So make sure you watch them both. So a rocket car is heading down a track with an acceleration of 12 meters per second squared that was caused by a set of thrusters putting out 100,000 newtons of force. It's traveling so fast the air is applying a resistance force of 25,000 newtons. Period. Determine the mass of the rocket car. So here we're going to try and figure out the actual mass of the rocket car. So first things first, you want to draw yourself a force diagram. So I've got myself a rocket car. I do a great job of drawing it. ROCKET. That is embarrassing as, wow, you'd think that I can do this, I swear. There we go. Alright, rocket car. So I've got gravity's pulling it down. Now I'm just going to write mg because mg equals fg. So I'm just going to write mg for all these because it's the same number of letters. And then you've got a normal force pushing it up because it's moving horizontally. And then it's going in this direction with the thrusters. So we got our normal force by those thrusters. And then we've basically got a resistance force, so a second normal force by the air over here. Now these forces here are balanced. And these forces here in the x-plane are unbalanced. So you gotta draw a good force diagram or you're in trouble. Now since the thrusters are putting over here, so thrusters, since it's pushing to the left, we are going to be accelerating to the left. Now notice how I don't put my acceleration arrow touching my system. The only thing that ever touches my system are the forces. So this is my force diagram and my setup. So now I'm going to break out my net force equation, and I'm going to try and solve for this mass of the car. So if you look, I'm accelerating in the x-plane. So when I do my net force equation, I'm only going to look at the x-plane. And so thus I'm looking at an acceleration in the x-plane. That's what the x's mean. So I'm going to sum all the forces I see in the x-plane and set them equal to ma. So when I sum the forces, I have the positive normal force from the thrusters, so I'll call it FNT. And it's actually negative because it's pointing to the left, plus the normal force from the air pushing against it equals ma. So now it's a matter of subbing and solving. So the thrusters are pumping out the 100,000 newtons. Then the air is pushing back with 25,000 newtons. Set that equal to the mass. I have no idea. But my acceleration is 12, but it's pointing to the left. So algebraically, this is going to be a negative 12. Because again, the direction tells me my plus or minus sign. So now, all that's left is algebra. And now that I'm back from the magical algebraic computer, I have a mass equal to 6,250 kilograms. So that is the mass of this rocket car. So that's kind of the first step. Real easy. Draw your force diagram, net force equation for the plane that you care about. Add up all the forces as you have drawn them in the appropriate planes. Solve whatever you happen to need to know. So, like I said, I did this in two parts because some people get confused. Because let's go and let's change things up. Let's look in the y plane now. So the rocket car then goes up a ramp, so it's launched straight into the air with its jet engine still applying a constant force of 10,000 newtons, and the air resistance is still applying that force. So probably should put a question in there. We want to know now, what is the acceleration? And we also now know from our previous problem that the mass is 6,250 kilograms. So, same steps. Draw my force diagram. So I'm going to draw myself a rocket car with a mass of 6,000. What are you doing, computer? Why does it always do this to me? No. Why are you thinking? Don't think. Okay, sorry about that. Computer hated me. Okay, we're back. So I'm drawing my rocket here. So 6,250 kilograms is the mass. Oh, look at that beautiful rocket picture. It's gorgeous. So now the thrusters are applying that normal force up. We've got gravity's pulling me down. And we have the air is also pushing me down. And we want to know what's the acceleration. So that's my force diagram. I have no left or right forces here. And so when I go to create my net force equation, I'm going to sum all the forces I see in the y plane and set them equal to ma. And so again, I'm looking for a vertical acceleration. That's what the y means. So now I'm going to add up all three of the forces I see in the y plane. So I have a positive normal force due to the thrusters. Then I have negative mg, and then I have a negative force normal due to the air equals ma. So now substitute in everything I know. So the thrusters are still applying that 10,000 or 100,000. Gravity is mg, so 6,250 times 9.8 minus that 25,000 by the air resistance equals 6,250 A. So now I just got to solve for A. So let's do some algebra. All right, so A equals, survey says, 2.2 meters per second squared. So even if this car were to go up a ramp and become airborne, it would still accelerate towards the sky. Don't know how aerodynamic it would be, but it would still accelerate towards the sky. So before you saw us solve a net force problem in the x-plane, and you saw how that worked, and then you saw us solve one in the y-plane, you saw how that worked. So technically they're both set up the same way. The most important thing is making sure that when you write this equation here, you're reminding yourself what plane are you going to be looking at. So when students often make mistakes, it's when they look at this x-plane and they'll include gravity in here. But this is for the x-plane only. So we would not include gravity, we would not include normal force, no matter what information we're told. All right, so you just want to make sure you're doing all the summing, all the forces in a given plane, set them equal to ma, and find what you need to find. Hope that helped. Enjoy.